Welcome to this week's Operational Analytics Live Tech Talk. My name is Pradeep Banat. I'm the Director of Marketing for Action's Analytics Products, and I'm joined by Emma McGrattan, our Senior Vice President of Engineering.
Hello.
Emma will give us a deep dive into the technology required to build an effective operational data warehouse. According to a recent survey of CIOs by Gartner, 81% of them believe that advanced analytics will have a positive disruptive impact on their business over the next 5 years.
This is also underlined by a survey conducted by the Bain Group, which goes into a little more depth. It revealed basically that companies that use analytics frequently in their decision making are 2 times more likely to have top quartile financial performance for their industry. They're 5 times more likely to make decisions faster than their competitors, making them more competitive. And they're likely to execute decisions as intended. So they're likely to do things right the first time. And they're also 2 times more likely to use data more frequently when making decisions. Why do we need newer technology in analytics? Some of the drawbacks of the existing analytics infrastructure and products that people use today, they can be very expensive to acquire, deploy, and maintain. So for example, if you're using a dedicated hardware technology, an appliance model, that can be very expensive to upgrade. It can be too rigid in terms of platforms. It might be that the analytics database you're using is only available in the cloud or only available on-premise. Sometimes you need a mix of both. Many solutions don't scale. There's a lot of commodity analytics products on the market. The downside of some of those is that they really don't perform very well. Performance can be unpredictable. Some of the products have very poor abilities to spill from memory. They don't spill gracefully. So if they do consume all the available memory, they'll end up thrashing, killing your performance, your responses to the queries. Often data can be stale. For example, many of the Hadoop-based SQL implementations aren't really designed to handle real-time update. Typically, you'd add new data sets in batch overnight into a Hadoop system, which means people doing queries over the next day are always looking at yesterday's data, which isn't ideal for many situations. And, some are just purely expensive. They provide very poor time to value. They're very complex, hard to implement. So what do we do? The big emerging trend today, the next big thing, is the operational data warehouse, or ODW. It's basically a data warehouse. It has all the strengths of a traditional data warehouse. It's fast, it's responsive, it's flexible, but it also has the ability to handle updates very efficiently. So you get to see data that's fresh. That's like a major differentiator between a traditional data warehouse and an operational data warehouse, that it handles updates. Data lakes can be great at storing data. They scale really well, but they don't handle queries efficiently. So they're basically very slow to query, even though they can be quite large. This is a good place to store your data, but it's not a place where you want to do high-speed analytics. People want to see data that's in the moment. They want to see how the business is performing, minute to minute, hour to hour. They don't want to see yesterday's view. That's just not good enough. So the ODW is really the answer. It has the power of the traditional data warehouse, the scale of the data lake, and it's cost effective. So it has the economies of the cloud. It can run on-premise or in the cloud, and it can run well on commodity hardware, so you don't need those expensive appliance-based solutions. Action's vector analytics database is designed to have all those positive attributes. It runs on commodity hardware, scales really well, and is very performant. So the chart on the left-hand side of this slide shows you the landscape for data warehouses. On the bottom left of the chart, we're talking about data that's very predictable. You know what queries people are going to do. So you can pre-index the data. You can create OLAP cubes, for example, in advance. At the top right, people are doing more ad hoc queries. They're doing data discovery. They want to look for insights in their data. They're doing a lot more ad hoc kind of queries. And they're basically taking a very iterative approach. In the middle, people are running queries. They want to explore the data a little bit more, and they might iterate over and over again, doing lots of ad hoc queries in a row, which might not be optimized, not what the administrators expected. So performance can be very, very lumpy. So the ODW has to address both of these extremes. It has to scale to the scale of the data lake, and it needs to provide near real-time performance and real-time fresh data.
Some examples of how organizations are using the operational data warehouse include media and advertising companies looking at the performance of real-time ads and promotions, logistics organizations tracking real-time delivery and spend, financial organizations need to detect fraud and issue alerts in near real time, telcos need to manage quality of service, to name just a few. I'll share with you two real examples of Actian Vector customers. In this example, we have a leading real-time auction site that needs to provide potential sellers with a real-time market price for an item they wish to list. Having an accurate market price means the auction site is more profitable because items are priced correctly and their customers are more satisfied because their goods have a higher probability of getting sold. In the second example, an organization called Expandium in Europe provides real-time quality of service applications to telecommunications operators who need to meet critical SLA objectives. In one example, they have a large telco with 20 million customers. Expandium's dashboard provides the carrier with a real-time view of the quality of the service they're delivering across their customer base. An Actian Vector database running on a 12-node cluster provides the carrier with the ability to analyze 4 to 5 billion transactions per day, maintaining a 10-day window, which is between 40 and 50 billion transactions. Traditional databases can't handle the update volume while providing the ability for the carrier to drill down to individual drop calls. That concludes my section of the presentation. With that, I'll hand over to Emma.
Hello, my name is Emma McGrattan, and I'm Senior Vice President of Engineering at Actian, and I have responsibility for Actian's analytics product portfolio. Actian Vector is actually a family of products, and they can run on anything from a Windows laptop right the way through to the largest cluster. There's three things that we focus on for developing the Actian Vector technology. The first is performance, and that's what we're known for, right? There's nothing in the world that performs as fast as Vector does, and we've proven it time and again through benchmarks. When we look at performance, we look at everything from maximizing the capability of a CPU, making sure that we get every last clock cycle out of the CPU. Looking at storage, right? Storage is a big contributor to performance characteristics when you're dealing with large volumes of data. So making sure that we've optimized our use of storage. And then memory, right? So that's the third component here, making sure that we're using memory efficiently and not just RAM, right, which is where people typically think of memory, but actually looking onto the CPU and the fact that it has a number of caches built into the CPU that provide us with a few meg of storage that we can use. So more about that later. We've also built the product so that it fits into the existing BI and analytics ecosystem. So what that means is that we've focused on the SQL standard, and in fact, we have a representative on the SQL language body. And what we want to be able to do is, as people have existing integration workloads, right? They've built out their ETL workloads, they've built out their BI and analytics workloads, and we want to fit in the middle there, right? So to be able to support all of the integration tools that are most commonly found out there, and it might be Talent for ETL, it may be Informatica, whatever it is, we will work with that environment. And then to be able to serve the needs of tools like Tableau and Power BI and Click. So being standards-based means that it's really easy to slot into that ecosystem and that end customers don't have to rework stuff that's already been done. They can just point those workloads at Vector and it'll handle it better than they've ever seen before. We also have been very open in making sure that we support open standards and open source. So ODBC, JDBC, .NET are the industry standards that you'll see being used for accessing data. We also, on the open source side of things, we've built out a solution in Hadoop that leverages Spark and that enables us to integrate with that whole open source ecosystem that's out there. The third thing that we focus on is the fact that a lot of our products are deployed in mission critical environments. It's 24/7 availability required of us. It's the ultimate in protecting the data, securing the environment. If a customer environment goes down, they want the reassurance that we will get them back up and running as quickly as we possibly can to minimize that outage, and then we will do root cause analysis. So we have an amazing support team, and they're here to support all of your efforts. That we look forward to collaborating with you. So I mentioned that Actian Vector is a family. There are three members essentially to the family. So the first is Vector, and Vector is a single node analytics database measured as the fastest in the world. It runs on both Windows and Linux. Typically with Linux, we'll see about a 20% performance advantage over Windows, but we do have customers that run both and some pretty large deployments on Windows too. One of the problems with the initial Vector implementation on Linux was that a typical Linux server is limited to about 10 terabytes of data. The CPU power in the server, together with the memory and disk available, typically we put that rule of thumb on it up to about 10 terabytes. So when data sets scale beyond 10 terabytes, we needed a solution that could scale with our customers. And that's when we came up with Vector H. So Vector H is a identical product to Actian Vector, except the I/O is optimized for HDFS. And HDFS is the distributed file system that sits under Hadoop. It's a file system that is designed for commodity disks, and it assumes because they're commodity disks that they're going to fail more frequently than the more expensive disks. So it's got redundancy and things built into it that we can leverage with Actian Vector to provide the same type of performance that we're known for on Linux and Windows, but on a Hadoop footprint. It's quite amazing. It scales linearly. So let's say you were getting 1 million transactions an hour on your single server, and you scale that to 10 nodes of identically configured hardware, you can expect that you would get 10 times that throughput, or 10 million transactions in an hour. The third product that's part of the Vector family is Actian X. And this was a product we brought to market last year. It combines the Ingress OLTP database, which is actually how I started at Actian, with the X100 engine, the engine that makes the analytics solution so fast. And in a single footprint, we've got the ability to not only do high-speed transactional data, but then to analyze the data that's generated from those transactions. So this is a great upgrade path. It's a natural upgrade path for our existing Ingress accounts, but it's also great for new development, right? So if you come across a greenfield opportunity where you know that it's a mostly transactional app, but high performance reporting, business intelligence and analytics is going to be required, then this is a solution that you should definitely look at. So on the previous slide, the X100 engine was common to all three products. What we're going to do now is to take a look under the hood at the X100 engine. So what you'll see on this slide right now are 6 different things that make Vector X100 engine unique. It's the combination of all 6 that make it unique. You will find some of these capabilities in our competitor products, but not all of them, and not designed in from the ground up. And the first is vectorized processing, and that's where the name vector comes from. You can think of a vector as an array of data, and what we're able to do with vector is, instead of operating on single records at a time, we can operate on arrays of data at a time. And vectorization is something that's available in commodity CPUs, whether they're from Intel or AMD. It doesn't require specialist and very expensive hardware. This will run, as I mentioned earlier, on your laptop, and it will really impress you. The second thing is that we developed Vector to take advantage of the fact that modern CPUs have an on-chip cache of several megabytes, right? So they have multiple caches, different layers of caching. And our thought is that if we use the chip cache for staging data, then as we need to access that data, it's really nearby, right? And it's a couple of clock cycles to take it from where it resides in the chip cache into the execution registers. So that's really clever and works really well for us. The third point on here is that you'll see we call ourselves a second generation columnar. Now, columnar storage makes sense for analytics solutions because the typical access method for analysis is columns at a time, right? So let's say you're dealing with, get me the average price paid, right? You don't want to read the entire record for the purchase. What you want to get to is just the price column in that data record. So what we do at Vector is we store the data as columns. We actually store it as vectors. I mentioned the vector in point one, mini arrays. These are compressed vectors as they're stored on disk. Now, the reason we call ourselves second generation columnar is that we've actually cracked the code on how to do updates in a column store. That's a real challenge for many column stores, and Vector's cracked that challenge. The fourth thing on here is compression, smart compression. And we call it smart because based upon the type of data that we're compressing, we'll choose the most appropriate compression algorithm. User doesn't need to know anything about compression or the algorithms available to us. The fifth thing on here is storage indexes. So essentially what we wanted to do was to make Vector as simple as possible. And one way of achieving that was that we automatically build indexes on the data as it's been loaded into Vector. We keep track for each data block that we're writing to disk. We keep track of the minimum and the maximum value within that data block. So then when we're solving a query, we're able to identify which of the blocks that are going to participate in solving the query and which are the ones that won't, right? So we don't obviously bother reading the blocks that won't participate in solving the query. So it leads to really efficient I/O patterns for Vector. And then the sixth thing on here is multi-core parallelism. And we've designed Vector for the fact that many servers today ship with, over 100 cores in it. And in fact, some have over 200 cores within them. What we want to be able to do is to maximize our use of all of those cores, right? So that was important for us and one of the considerations in designing Vector. Here what you'll see is the front page of some amazing benchmark reports that we ran earlier this year. On the bottom of the screen, you'll see a link through to where you can access these benchmark reports. But essentially what we did was we hired an outside consulting group to run the UC Berkeley AmpLab Big Data Benchmark. And they ran that benchmark at 1 terabyte, 5 terabyte, and 10 terabyte scale against Vector, Microsoft SQL Server, Amazon Redshift, Snowflake, and Cloudera's Impala. And what you'll see on the screen here is that when we compared our performance against SQL Server, we were 10 times faster. For Redshift, we were 14 times faster. Snowflake, we're 20 times faster. And for Impala, we're 100 times faster. One of the things that you don't see, because these are just the covers of the reports, is that as the query complexity grew, our performance differential grew, and as the number of concurrent users in the system grew, our advantage over the competition grew as well. So as data volumes grow, as data query complexity grows, and as the number of users grow, our lead over the competition grows as well. So an amazing space to be in. So now just to talk about, some of the other things that make Vector so special, I kind of group these into three very large buckets. The first is enterprise grade, right? So what's important to us is to be able to support existing workloads. So whether those are integration workloads, BI and visualization tool workloads, we find that if we focus on supporting the standard, then those workloads will just work with Vector. And for many cases, we've gone to customers, installed Vector, loaded their data, and then we will take their existing Tableau or Power BI reports, point those reports and dashboards at Vector, and it will just work. So it really can be that simple if they haven't done anything particularly complicated. As I've mentioned a couple of times, we're ACID compliant, and what that means is that we bring transactional integrity to Hadoop. And as you say, you commit a body of work, that body of work is reflected in all subsequent transactions. We also use what's called a write-ahead log file, so that should the system fail for whatever reason, before the changes that we have seen in the system get committed to disk, they'll be in that write-ahead log file, and when you restart the failed system, it replays that log file, and you will never lose a transaction. We guarantee that transaction integrity. The update capability, I can't stress enough. The biggest disappointment to me is that people do not expect this on Hadoop, so people aren't looking for us because they don't know or don't imagine that anybody can provide this capability. It's unique to us, and I would be really grateful if you could get the word out about that. And then the last thing on the enterprise grade category is our DBMS security. And that's important enough that I actually have a slide where I call that out separately. Performance is what we're maniacal about. So it's executing queries really quickly, supporting a high concurrency, so a large number of users hitting the system at the same time, which is what concurrency is all about. Being able to figure out the best query execution plan for a query. That's really important, right? As you execute queries on the system, you want that to be the best possible plan. And typically with a query execution plan, you look at the query, you have an understanding as to the characteristics of the data, and you make sure that you come up with a method of executing that query that is the most efficient given the data characteristics that you're dealing with. And the last thing under performance is our use of Yarn. We have a unique capability with Yarn where we're able to grow and shrink the resource pool allocated to Vector. Yarn was actually designed for short-running jobs. Vector database, you anticipate, starting it when you install it and never having to shut it down unless you want to perform some kind of maintenance or an upgrade, for instance, that would require that you take the system down. And what we're able to do with Yarn is actually to identify the minimum resource pool that Vector can run within, the optimal resource pool that you want Vector to run in, and we can shrink and grow that pool based upon other activities in the system. So for instance, at the end of quarter or end of year, you may want to allocate more resources to your ETL jobs because it may be that those are the most important jobs to you at that moment in time. So you can scale back the resources allocated to Vector, reassign those resources to ETL, and then when you're done with all that ETL processing, you can have Vector go back to the previous allocation of resources without having to stop and restart the system. So that's huge, and that's something that's unique to us, a really smart use of Yarn for that. Our Yarn integration also gives us the ability to operate in a mixed workload cluster. So we don't require a dedicated cluster for Vector. We do recommend that we put Vector on nodes that are dedicated to Vector because it's a beast when it comes to CPU consumption, memory consumption. But if you don't have the luxury of being able to define a set of nodes that are dedicated to Vector, and we can, within the context of Yarn, constrain Vector to a given set of resources. And then the last bucket on here being open. We are cloud agnostic, which means that we're adopting support for all of the cloud vendors. We focused on the big two, right? Azure and also AWS. But there's nothing to prevent us implementing our solutions on Google Cloud and Alibaba, IBM Cloud, Oracle, whoever it may be. But we focus on the big two to begin with. We're also Hadoop distribution agnostic, recognizing that people will settle on a Hadoop provider dependent on whether or not they really like the services provided by a given vendor or the customizations that are part of that Hadoop offering. So we support Hortonworks, Cloudera, and MapR. Also standard Apache Hadoop if that's your customer's choice or your choice. We've designed it to be an open collaborative architecture. And what I mean by that is that Hadoop is an ecosystem, and where there's a lot of really cool things going on, and we wanted to be able to be part of that ecosystem, so we've designed for that. So on this slide, what I've attempted to do is to show you how we would see Vector fitting in the enterprise. So on the left-hand side, we've got a multitude of data sources, right? So it might be some local databases. It could be some streaming data coming in from IoT applications or a enterprise service bus. It could be data coming in from remote data centers, or it could be cloud-based applications, right? So it might be Salesforce, it might be NetSuite, it might be Amazon S3. We can take that data from any of those sources using a variety of methods. So it might be that we use traditional ETL tools like Talent or Informatica. It might be that we've suggested the use of Dataflow, which is an incredible piece of technology that you should learn more about. We also have an Actian technology called Data Connect, and that's another way of connecting data like Salesforce and bringing it into Vector. And then from the open source side of things, we also have a Spark connector and a Spark loader. So if the customer is really heavy on Spark for ETL, that is something that we support and encourage as well. So those are the various methods. We also support replication and change data capture and other ways of getting the data in here. There are some customers that don't want to move data into vector, that they would much rather leave their data where it is and to be able to access that data from vector. And that is something that we can provide support for as well. So in the middle of the diagram, well, slightly to the right, you see Actian Vector sitting on HDFS and with Spark integration. And above that, you'll see that there's a variety of data sources that we can get to, including Hive, Postgres, Amazon S3. It doesn't really matter. There's a whole variety of them, and we support all of them. And then to the right-hand side, what you'll see is the user base that we support. So we have seen in a lot of organizations that the business users are given access to tools like Tableau and Click and Power BI and Business Objects, and they want to be able to query that data, issue their own ad hoc queries against it, and that's something Vector supports. So powering that business user and giving them the ability to run what-if scenarios and opening that up to ad hoc querying is a amazing capability and something that Vector provides. And then what you'll see on the bottom of that is the data scientists and the data engineers who want to access the data from a different perspective, right? Maybe they're using AI, ML, maybe they want to write applications using Spark SQL, Scala, or Python, and those tool sets are all supported as well. So it's bringing data in or ingesting data from any data source, accessing data where it resides anywhere, and then serving the needs of any user, right? So it's the business user, it's the data scientist, and it's the data engineer. I do hope you learned a lot. There is a lot of really detailed and great information out there. So thanks for your time and your attention.
Thank you, Emma.
Now I'm going to move on to show you how easy Vector is to evaluate. I'm basically going to walk through the process I ran through. It took me about 2.5 hours to evaluate Vector when I first joined Actian. What we do is provide you with the product as well as a sample database of airline journeys across the US over multiple years, which add up to something like 165 million records to analyze. What I did, actually created a YouTube video, which you can see on the landing page as well, of my journey through the evaluation process using the evaluation guide pictured here. Basically, you download the package of software, install the database, create the tables, run some queries, put the results of your execution speeds in a spreadsheet and email them to us, and we'll send you a t-shirt. So that's basically the process. I'll step through that now. To get started, you basically visit a page at actian.com called Try Vector on the top right of this slide. Provide some of your registration details, and on the thank you page immediately afterwards, we give you the license key, which is good for 60 days. And you can cut and paste that into the installer of the product. This will also be confirmed in an email. So this is the package you download after you've registered. It includes the product itself, a set of SQL and DDL that can be used with Vector, and some sample SQL and DDL for use on SQL Server, as well as the on-time files folder, which contains the 165 million airline journeys data. We also provide the script to upload those in parallel. So the first thing you do is create the two tables. I just cut and paste these from the sample database into this tool, which is the graphical user interface to Actian Vector. It's called Actian Director. So basically paste them into the window, hit execute, and the tables are created. You can see them in the hierarchy on the left. Once you've created the table, you can decompress the data files and then run a script called parallel_load.bat, indicated at the top of the screen. Before you run it, you can use the time command before and after to give you an idea of how long it took to load. Typically it takes 10 minutes to run in parallel on your laptop, as long as it's running Windows. If if you don't use the parallel load, then it would take something like 50 minutes. I tried both versions. After generate statistics, which again is an easy process, you can execute all 9 queries together, and the results go into the tabs at the bottom left of that screen. So you can see the execution times for each query and the result set as well. And then you can record those in the spreadsheet we provide. And you can do the same test, same data, using the DDL we provide for SQL Server, for example, and one of your own databases. And then the spreadsheet will automatically calculate how much faster Vector is. And if you'd like to send that to us at the email address on the previous slide, results@actian.com, again on the top right, we'll send you a cool t-shirt. So hopefully you'll get a chance to evaluate. I've given you an idea of how easy it is, and they'll encourage you to give it a go. If you have any questions, again, feel free to ask them, and I'll answer them offline. Or we can also, I've received a couple of questions on the chat. The first of those questions is on somebody wants to know exactly what platforms the product runs on. It runs on Windows and on Linux, the popular distributions, and it also runs on popular distributions of Hadoop. We use HDFS as our file store on Hadoop, but we have very compressed data, and we do the updates ourselves, so it's more efficient than other SQL implementations on top of Hadoop. So we work with MapR and Hortonworks, for example, all the popular Hadoop distributions. And in the cloud, as I mentioned earlier, it runs both on AWS as well as Azure. So it's in the Azure marketplace and in AWS as an AMI. The next question is about somebody wants me to give them a use case, an example of using Actian X, which I mentioned briefly. So Actian X is the typical row-based relational database and the columnar vector engine in a single product. Like a good use case of that is what Oxford University Health does. They perform a lot of clinical trials. So what they do is record all the clinical trial data in the relational row-based side of the database. And when they want to do a report, they basically need to analyze that data, and they use Vector or the X100 engine built into ActionX to do that analysis really efficiently. So that's one example. HSS Hire is another example, who are a UK-based hardware rental company. So they kind of rent you tools, or even cement mixing trucks. All their order management system is in ActionX. And they can do sales analysis using the vector side of the product. I don't see any other questions. Again, send your questions to results@actian.com, and I'll make sure they get answered quickly. Thank you for joining, and that concludes the presentation for today.